So with insulative coatings, or with coatings in general, we routinely process wire materials, strands, cables, all different forms. There's two broad categories that we kind of speak about our coatings. One umbrella is under dielectric coatings, and the other umbrella is kind of under lubricious coatings. So dielectric simply means a material that can transmit an electrical force without conduction. And so you think of an insulator, it prevents electrical leakage and short circuits. So these coatings are under the dielectric umbrella because they're able to be coated or jacketed over a conductor, and they allow some of the electrical energy to flow along the inside without impeding. However, it doesn't allow that electrical energy to penetrate or to leak through that coating. Under these dielectric coatings, some of the most widely used in the industry are in the extrudable thermoplastics, fluoropolymers type category. They combine a great suite of benefits, including a combination of strength, durability or toughness, and of course, the dielectric performance that's needed in conductors for medical. Some of the leading ones that we see widely used, the most widely used that we see is ETFE, or ethylene tetrafluoroethylene. It's really known for its mechanical strength, abrasion resistance, impact resistance. It's widely used for insulating conductors, supporting CRM and neural leads. PFA, PFA, which is perfluoroalkyloxy, is a higher melting point fluoropolymer. It actually has a higher surface temperature than what ETFE does. So it melts at about 260 C, or it can be within service at 260 C, compared to ETFE, which its upper surface temperature is around 150 C. And it's definitely more lubricious. And that's one of the reasons is that folks may leverage a PFA coating for applications that the conductor may be inserted inside a lumen. It just provides a little bit more ease of pushability due to the lower resistance. FEP, or fluorinated ethylene propylene, it is not used near as much from what we see as ETFE and PFA. However, it is used in some applications where you may want a little bit softer coating or something that's slightly more flexible. FEP has a service temp that's almost right in between ETFE and PFA. It's definitely not as durable as ETFE, and it's not as lubricious as PFA, but it kind of sits right in that middle ground. And again, that's just not something that's as widely used, but it is available. Finally, we do have a extrudable PTFE. It is trade name is called Moldflon. PTFE, or polytetrafluoroethylene, is mostly used or known for its lubricity. So it is orders of magnitude more lubricious than ETFE, and it's kind of that gold standard for getting a material that's used where lubricity is one of the primary functions. The nice thing about the Moldflon PTFE compared to a sintered or just a true PTFE that's paste extruded is that the extrudable PTFE has some groups on it. We believe that it's like PFA groups. So it allows the material to be extruded over the surface and encapsulate like a strand. It has a surface temperature of around 260 C, so near that of very similar to PFA. With the lubricity, and the dielectric strength is in the same neighborhood. For instance, with ETFE, you can kind of count on about 1500 to 1800 volts per mil. Very similar with PFA. Moldflon is in that same range as well. All of those fluoropolymers can be mixed with a colorant that allows various colors to be available for those materials. Folks typically use those in devices to airproof or to color different conductors to make ease of assembly in the device. Another option that we can do with extrudable coatings is to apply a fluting tip in the die geometry. What that allows is small ribs or lobes to be placed on the inside or the outside of the coating. And that can be used to enhance pushability due to the air pockets that are then present between the coating and whatever tube or part of the device that it is being inserted. What we find with dielectric coatings, of course, is very common applications are within CRM or neuro. Many EP catheters now, are leveraging similar technology in that space. Outside of extrudable coatings under that dielectric umbrella are enamel coatings. And what we find is that the most widely used enamel coating for dielectric performance in med device happens to be polyimide. Polyimide has an extremely high performing dielectric strength compared to any of the fluoropolymers. In fact, it's roughly 3 to 4 times as strong. You can get, we said that many of the fluoropolymers were around 1500 to 1800 volts per mil. You can get that same dielectric performance at about a third the wall thickness. So roughly a third of a mil, you can get that 1800 to 2000 volt performance out of a polyimide. So that truly enables the device designer to be able to build a construction with good dielectric strength where you need to reduce the size of the conductor to try to conceal the footprint of the device. So within catheters, within certain regions of the body, when you need to downsize and reduce that diameter, polyimide may be something to consider. An enamel coating compared to an extrusion operates very differently. It acts differently on the wire itself. The extrusions just kind of act as a jacket around the construction. However, in contrast, the enamel coatings actually adhere to the surface. So some advantages for an enamel could be if you're going to be coiling a material or you need some abrasion resistance or extremely tough, they adhere directly to the wire. However, if you're needing to insulate a strand or a cable and you want to maintain flexibility, that's where an extrusion would be more appropriate. Some common applications for enamels are diagnostic catheters, conductors, and those, like we said, with where you have limited space. The other umbrella outside of dielectric, like I mentioned, is lubricious. So lubricious coatings, the first one that everybody thinks of is PTFE. The polyfluorotetraethylene is widely known as Teflon. Many of you leverage that within your houses with cookware and such. Well, just like food doesn't stick to Teflon pans, the PTFE allows guide wires and catheters and other wires to more seamlessly flow through, whether it's within the body, the vasculature, or within a device. And so common applications, of course, for PTFE would be guide wires and catheters. We offer the extrudable PTFE in-house at Fort Wayne Metals, but we also partner with converters for a paste extruded or a dip or a spray PTFE that can be applied either reel-to-reel or discrete pieces. And we partner with folks such as Merit Medical for their Duraskin and Lubraskin. A couple other coatings just to briefly mention. Nylons are great for protection, for abrasion resistance. It's a very tough coating. Doesn't give you the dielectric performance or the lubricity, but it's another reason to potentially add an insulation to a strand. You can get different colors. You can get some extra abrasion layer between your strand and whatever pulley or whatever system that it's being rubbed against. One common one that we use is acrylamide, which is a polyamide, not to be confused with polyimide, but that is available in Fort Wayne as an extrusion. And finally, just to touch on PBAX, which is the polyether block amide. It's great flexibility, durability, known for its biocompatibility, and also the ability to be bonded to other layers or other coatings. So many folks use PVACs in catheter applications where you need to bond one layer to another. You may want to coat it with a hydrophilic coating for wet lubricity when it goes into the body. So that's a high-level subsection of the different coatings that we offer. And finally, once you get the coating on the material, many of our customers and device designers want to be able to weld the conductor or join the material with a crimp or a component. And so rather than leveraging a mechanical stripping process that can damage the wire and is a little bit more difficult to control tolerancing, Fort Wayne offers laser ablation that is able to remove the coating with a pretty clean shoulder, as shown in the upper right picture. And it allows us also to do customized zones where we can provide stripped regions within a length of material that will allow the device designers to do various terminations along that conductor. Our lasers are specifically geared towards ETFE, which we find is most widely used in the industry. And we do have partners and conversion partners to be able to ablate other coatings such as PFA or polyimide as necessary.